we're gonna talking about chapter 1 and chapter 2. It's really basic for the DC circuit. Okay. The first over, I wanted to identify the coefficient the base and exponent. Okay. All right. So they have they contain the three parts. Okay. So for example, right there. Let's say X, E, and A. For this case, it is the base. And so usually that is always the number. It's like 10, okay? And A is the exponent that was determined how many place decimal was moved. How many places the decimal was moved to obtain coefficient. Okay. And that was coefficient. Okay. That is the coefficient. That should be usually the greater than, it depends, right? But that is usually the constant number. Okay, constant number. So it depends on scientific notation and engineering notations. That could be, as the constant number. So that was the example. For example, 5 times 10 to 3. That was coefficient. 10 is base. 3 is exponent. Okay. Right. All right. So now they have two types to express the number, but the first over, we're going to learn about scientific notations. Okay. So the scientific notations, there is for few the conditions. Okay, few the conditions. So scientific notation. So coefficient should be 1 to 10. Okay, 1 to 10. All right. So, for example, write the number 0.00000374, but using scientific number. Maybe, as I said before, maybe exponent is fine, but here 3 and 3. But do you remember like this one? So that should be here 3.74. The decimal 1, 2, 3, 4, 5. So, oops. So 10 to 5. Okay. Because again, that should be coefficient satisfy 1 and 2, 5. Okay. So the exponent 5 and coefficient 3.74. Okay. In engineering notation, that they have very similar to the scientific notations, but the except all exponents will be multiple of 3. So that is condition, or exponent will be multiple of 3. Okay. All right. So for example, 5,500 here, and using engineering notation was 5.5 10 to 3. Why? Because as we learned before, exponents should be multiplied 3 times, and that is for the one of the option here. Okay, maybe how about this one? Here. Okay, that was 800 times 10 to 6. Why? Because the exponent multiple of 3. That is requirement which had to satisfy for the engineering notations. Same thing, the reverse one. For example, write this one, 0.003. That should be 3 to 10 to minus 3, minus 3. It doesn't matter, plus, minus, there should be multiple 3, okay? All right, so 4 things we have to know about the prefix. And also you have to make a practice for the unit, the conversion, okay? So, the 1,000 is 10 to 3. That is what? That is kilo and K. So 1,000 is 1K, okay? Maybe, how about this one? 0.001, that was 10 to minus 3 is milli, and that was small m here, okay? Small m here. Okay, so that means 1 small m here. So how about the 100, 1,000, 1,000? That was 10 to 6. We're gonna mega was the m here, okay? So that means 1m. But how about this one? 0.000001. So 10 to minus 6, that was micro. That was like this one, so 1 micro, okay? That is very important, okay? And we have the practice for we'll have practice for the convert 0.0000245 microsec. So that was we have to the decimal 1, 2, 3, 4, 5, 6, right? So 24.5 10 to minus 6. Why? Because 10 to minus 6 is micro, right? Micro. So we are looking for that number. So, that is the one number rule, the converter between the few different units. So you needed to practice a lot of time, okay? All right. So that